Hi, this is Alex from devstories.eu. Snowflake and Snowpark Python, Episode 2 of 17. What if you could write pure Python, but have it execute as hyper-optimized distributed SQL? That is exactly the paradigm shift we are covering today with an introduction to Snowpark. Traditionally, working with large datasets in Python meant pulling data out of your database. You write a query, pull the data across the network into local memory or an external processing cluster, run your transformations, and then push the results back. This approach creates network bottlenecks, increases infrastructure costs, and introduces security risks by moving data out of a governed environment. Snowpark flips this model. Instead of moving data to the compute, Snowpark pushes the compute down to the data. A common misconception is that Snowpark is an external processing engine. People often assume they need to spin up and manage a separate compute cluster just to run Python code. It is not. Snowpark computations run directly within Snowflake. You are using the exact same virtual warehouses that execute your standard SQL queries. There is no new infrastructure to provision or maintain. When you write code using the Snowpark Python API, you are interacting with a DataFrame object. This feels very similar to working with familiar Python data tools. You chain operations together, defining how to select, filter, group, or aggregate your data. However, the Snowpark library does not execute these operations locally. Instead, it natively translates your Python DataFrame operations into complex SQL constructs. Snowflake then processes these SQL statements using its standard execution engine. Here is the key insight. Snowpark uses lazy evaluation. When you define your data frame and apply various transformations, no data actually moves or changes. The Snowpark API simply builds up a logical plan. It records your intent step by step. Actual execution only triggers when you call a specific action, such as asking the system to return the final results or write them into a new table. This lazy evaluation model, combined with native SQL translation, drastically reduces data transfer. Consider a scenario where you are a data engineer tasked with filtering a billion rows of transaction data to isolate a few specific anomalies. You write your filter logic in a local Python script. Because the execution is delayed until the action is called, the API has time to optimize the entire chain of operations and translate it into a single, highly efficient SQL query. The actual filtering happens entirely inside Snowflake. The database does all the heavy lifting. The only data that travels across the network to your local machine is the final, small subset of anomalies. You just processed a billion rows using Python syntax without pulling a single raw record into your local memory. The real advantage here is keeping the developer experience native to Python while leveraging the database engine for what it does best. You write Python, but Snowflake executes SQL. That's all for this one. Thanks for listening, and keep building.